Welcome back. Back on my camping trip, I decided I wanted to have a way to charge my camera without running any kind of power from the van I was in. And the reason was because I just didn't want to get into that situation where something was going to be constantly charging and possibly running down the battery, and I didn't want to have to, start and run the van every once in a while and disturb my neighbors. So I figured, let me bring a backup. I took one of these 8-cell AA holders, and 8 AA's will get you 12 volts. There's a actual 9-volt battery snap, which I don't have, but what I ended up doing is I took some alligator clips, and this is a buck converter that bucks voltage down, and it's going to take an input between 6.5 volt all the way up to 40 volt and buck it down to 5 volt, and that's obviously in DC. And it has a rating of up to 2 amps. Now this was perfect because it already has a USB output on it. It has the screen on here that tells me how much voltage is coming in. There's a on and off switch on the top here that turns the whole thing on, and then the bottom switch here turns on the output, and there's a red LED that will glow once the output's activated. And I just ended up clipping this directly to the terminals here, and it worked perfectly. And the charger, which I have actually under the camera here and is in use, is a 1.8 amp output, 5 volt. So this is definitely just enough to power my camera, obviously, but my tablet actually needs a higher output. I think it's 2.1 or 2.4 amps, and this just doesn't quite cut it. So I started looking around the shop when I came back, and I came across, of course, the buck boost converter. Now this not only steps down voltage but also steps it up. This one has a rating of 3.8 volts to 32 volts input, and it will output anywhere from 1.25 volts up to 35 volts. No load, it's 18 milliamp load just on its own, and it has a 3 amp output maximum, so I figured this would be perfect. And I had other wire soldered to it, but since I picked up some spools on eBay recently, I decided I'm going to just make the ins and outs just different colors just to make it easier to read. Now it doesn't have obviously a output like this does where I can just read it, so I do need to use my voltmeter here to actually get the output set correctly. And I've already done that using a screwdriver and obviously connecting this to the output and adjusting this little tiny set screw right here. And this is one of those multi-trim potentiometers. And by the way, the reason how you can tell this is a buck boost converter is because there's actually 2 inductors, so it's using one to step up and one to step down. Now there's a good advantage to this. I need to get 5 volts out of this, and considering that the minimum is 3.8 volts, I can actually dip down below the 5 volt output and still get 5 volts out, even though I'm using a 12 volt source. So I figured, well, what else do I have that holds batteries like this that may hold bigger batteries? And when I had the camping gear pulled out, I remembered that I had a fluorescent lantern in there that I like it. It's nice and bright, has a nice remote, but the problem is it's a little too big and a little too heavy for the trip I was going on, and I have a newer LED one that's much lighter, so I went with that. But inside of it, it has one of these plastic holders, and when you actually put this into the base, there's 2 connectors that connect in here. So then I said, well, hell, why don't I just connect that right on there and rig this up and just basically make this into a portable power bank, and this will definitely have enough juice to run 3 amps for sure. And I can definitely put maybe a USB port or even 2 on here, no doubt. And one of the other things I kind of have to segue into, this little device here was something I was just tinkering with one night. The USB in and out here was actually from a dollar store extension cable, which was kind of junk. I was able to just pull these connectors right out and had these little tiny wires on there. So I just desoldered it, and I marked with a pen the black and red, obviously positive and negative, and the green and white terminals. I just use a green marker and the rest of it's white, and those are the data terminals. On the male side, we'll call it, the side actually you plug into the device, I left them completely disconnected. But on the socket side here, the side that you would plug your wire or your charger into, they're connected together, because a lot of devices, when they're connected, they want to draw the maximum amount of current available, and this acts kind of like a cheater circuit, I guess you could say. But one of the other things it does is it adds a little USB port, obviously with a LED light next to it, and that way if I plug it into something, I can test the output of it right away and see if it's working without having to plug anything else into it. And also I have a terminal block on the side, so if I want to, I can actually take another source of electricity, basically hook it into this terminal, as long as it's 5 volts, and I have a quick way to add a USB terminal to it. And then I did something with these little jumpers here. If you pull the jumper off, it exposes some pins, so that way if you wanted to take an alligator clip, anyway, if you want to take an alligator clip and just clip it to it to get power from it, you could do that. Or I have smart board connectors, which actually has a little plug that sits over that. So then I started thinking, after I put this together, there's definitely a better way I can engineer this. I can do it where there's a diode, so if you have power connected to here and you have this hooked up to something, it won't accidentally send the power into your device and fry it. The other thing I can make it do is actually remove the power completely from whatever device this is plugged into and use it to power the thing externally. So if you have a high current device that's actually drawing more than what the motherboard or whatever this is plugged into can provide, you'll be able to use external power on it. So I'm going to have to re-engineer this, and that'll be a thing for another video. But just tinkering around one night, I thought that came out pretty cool. It definitely has some uses for me, at least. And the way it's spaced out, I can still plug a charge doctor into this. Actually, yeah, it goes like that. This is actually the top side view, and that actually works out to be pretty good. But what I started doing after I had all this stuff out, I looked at this and said, you know, there's a lot of empty space, I bet, in the middle of this. And you're probably going to think the same thing I did. I already took it apart because the suspense was just killing me. And this is the point where I said, I'm going to actually stop what I'm doing and grab the camera. So I thought this was actually pretty neat. But there's a perfect cavity in there. There's more than enough room for what I want to do. And I said, well, there's got to be a way that this thing could just slip inside of there. And I'm going to make this the bottom. And without hesitation, this just slips perfectly in there like it was meant to be. That really couldn't fit in there any more perfect. And then I looked at it and said, all right, well, the terminals are on the top, and if you look at it, I already kind of inscribed positive and negative over here, and I got that from what's marked over here where the batteries go. And these last terminals are obviously the last connection points, so this is where you're going to get 12 volts from. You can probably connect in other areas if you wanted to tap off and get different voltages, but you would actually drain the batteries inconsistently across all the batteries, and I don't really want to do that. And I'll get into capacities in a minute. But you could see over here there's these little support rivets, and they don't actually go to anything. They just sit over here in the distance, and they just are for support. So this extends out into the middle so they can connect when you plug it in. So then I said, well, I can run the wires up into here and then drill a little hole out, bring the wire out, and possibly just pass it right through and then solder it from the side here, so I'll have a good positive connection on here. And then I thought, well, once you put the batteries in, it's always going to be connected to that, and even though it has a 18 milliamp draw, that will kill the batteries fairly quickly. So I figured I need a way to turn it on and off. So I started looking through my parts bin, and I had a bunch of these at one point, and this is really the only one I'm coming across. This is actually a little different than what I want to use. This is what's called an on-off-on switch. The middle position's off. You can go on this way, off, on that way. Now this can be used for a variety of different things, but if you bring power into the middle terminal, then you can use it to go to 2 different ways, or you could use it to select like an input jack and a battery, and if you want to go like DC in or battery and off in the middle for power, or for off, obviously, I've done that. But this particular situation, I'm going to use it to bring power down to the board and activate the board set for 5 volts, obviously, and then I can leave the other one either blank and have it for if I want to put another one in there, which there might not really be room for 2 of them because the switch is going to take up too much space, which or I could turn them sideways possibly, or I can put an actual DC jack on here and make it into an output of whatever the batteries are, and then that way you can plug in a little jumper cable and use it to power something else, another device, and then you can select between either the external power output or the internal 5 volt. And then I went, all right, well then what am I going to do for the USB portion of it, because this one had that nice USB output already on it. And then I picked this thing up. I says, well, I made that circuit the other day, that would be a pretty nice thing. And then I went, that's got a nice little square circuit board. I wonder if that'll fit. And yeah, that starts to slide in there and fits pretty well too. The only thing is it has that terminal block that I put in there. You can see it sticks out of the board a little bit. So if I want to use this, I can just desolder that and put this through, and I just have to mark out where this is going to hit and where that LED is going to hit, and that'll pop out, and then that way it'll also indicate when this is working. And I can also solder the wires directly to this board and then just use it for that. And then that way when I build my second better edition, I already have a basis to start off of, and this already went to good use. So I might do that. I was thinking of just going to the dollar store in the morning and picking up another extension cord, I guess you could say, and make another one of these, but I can't find my circuit boards, which makes me think I'm out of them. And I have to go back and either look at some of the other videos where I might have mentioned it, or just dig around a little deeper here in the Empire of Dirt, as they call it, and see if I have any more. If not, I'll have to order some, because there's no Radio Shack around anymore to just go buy stuff like that, unfortunately. So what I'm going to do now is figure out where I'm going to mount this switch. I'm thinking about putting in here so it comes out the front. I also have some LEDs and some resistors. These are 510 ohm resistors, and these are orange LEDs. I'm using 510 because I just have a list of resistors with 5 volt and 12 volt inputs, and each resistor color, or I should say each LED color, with the appropriate resistor for those 2 different voltages, because that's what I use the most, and I use the calculator to figure that out, an actual LED calculator. And I'm going to put 2 LEDs on this, and those are going to tell you which mode this will be in, and there'll be a label next to it once I actually get everything done. So break out the drill the holes. I'll drill the hole in the side over here for the wires. They'll come out and terminate. This is going to sit in here so well. It's like a press fit almost. And if I can try to engineer a way, I might find, hopefully it lines up well, but I might be able to find a way so I can drill a hole and be able to put a real skinny screwdriver in and still be able to access the little trim pot in there if I want to turn up the voltage and tweak it a little bit. Only thing is you'll have to remove one of the batteries, so you'll have to connect it to an external power source, I guess, when the batteries are disconnected, and tweak it that way, and then obviously reinstall the batteries. And then I think to hold this in, I'm going to probably use my good friend hot glue and just put a bead in each corner there just to hold that just from sliding out. And I really think that's not going to go anywhere at all. The other thing is going to be heat. I don't know how warm that's going to get, especially if you go to draw the full 3 amps. But then again, these kind of circuits are used in all kinds of different things that are enclosed like that, so it shouldn't be an issue, but I will monitor it once I actually get this put together, and we might have to drill some ventilation holes in there. But other than that, I'm going to try to assemble this as much as possible. Now, there is one thing you might not see in the table here, and that's D-cell batteries. I'm going to again have to go in the morning to go get them and load them in here. I'll probably actually grab them on my way home from work actually. Now I'm going to plan on using alkaline batteries with this because that's going to give me the most bang for the buck. Obviously there's copper zinc, and there's a few other ways, or you can do rechargeable. Now if you're doing D-cell batteries, or in the case of this little guy here, AA's, you're starting off brand new batteries with 12 volts. If you do it with obviously nickel metal hydride or any kind of rechargeable, they're usually lower voltage, like 1.2 volts. You're going to get 9.6 out of this. And going to capacities, on the A cells, you can find A cell batteries and alkalines at least, and those are usually the ones with the highest capacity that I found. You can get them 1700 to 3000 milliamp hours. D cells, however, are 12,000 to 18,000 milliamp hours. Now in this situation it's hooked up in series, so we're increasing the voltage, but the amperage is staying the same, so you won't be able to get more current out of it. The way you would be able to do that is if you had basically a double stack, a way to extend this, and you could put 2 batteries and you would actually have 16 altogether, and that would give you double the voltage, or still the 12 volts, but it'd give you double the current. And that might be a pretty interesting idea. I don't know if anyone's ever tried that, or if there's actually any battery packs out there that work like that. Now, you could, like I said, do this with rechargeable. Rechargeable batteries seem like they have a lesser current rating. I started pulling the numbers off of that, but I came up with 10,000 for the D cells, so obviously that's less than what you can get for the alkaline. I'm sure there's ones out there that are higher than that. But the thing is the voltage of it too. You have a higher overhead on the voltage. I know you're still stepping it down to 12 volts, but you have a longer way to go, I guess you could say. And as far as current goes, I'm pretty sure this is going to last me quite a bit. Like, I can pretty much guarantee I can bring this out at least on the 2-day trip while I'm out there, and charge my phone, my tablet, my camera, and maybe, obviously one at a time because I'll have one port on it, but I should be able to do all those devices the entire time, at least, like I said, the couple days that I go, and still have life left for the next trip, no doubt. Especially with those numbers, you think about it, that's pretty good. I could be wrong. I mean, you could probably draw them pretty quick. It'd be interesting to see. I mean, I have a charge doctor, so once I get all the stuff on here, I'll be able to plug this in and we could test it out and see how much current's actually being drawn. And we'll just keep our eye on the voltage, and I'll probably let my tablet die out and see how much battery life it will take from a new set of batteries. And I'm going to go out and most likely buy Duracell or Energizer or brand name good battery, just for consistency's sake. I bought other alkaline batteries I've had good luck with, and then sometimes I buy them and they're not so good when you get off brands. And sometimes I know people say battery's a battery, and I know you get good, you get bad. It's like anything else. So I'm just going to go with brand name just to keep it consistent. And let me go ahead and do some stuff with this project off camera, and we'll come back when I have some cool stuff to show. How about a progress update, huh? Well, I managed to get all the stuff marked that I want to cut, and I cut it. And you can see I actually cut out a hole for the USB connection. And as I started doing this, of course, most of the things I build tend to kind of go together as I do it. I don't really ever have a plan. I have an idea, but I don't have a plan. I know what I wanted to do. How do I implement it? And as I start taking it apart and making it, I find like the hole I can put stuff in, like I wasn't anticipating that. So now that I have holes and I have things where I'd like them to be, some things might work out great, some things might not work out so great. So one of the things you'll notice, I completely modified my little circuit here. I took off the input and took off some of the traces that I didn't need. So effectively we just have a USB port and a LED light and a resistor, of course. So of course now that will fit right in here. and it'll fit pretty good. And the only thing is it kind of wobbles back and forth because there's nothing to hold it right here where my thumb is. But of course it'll get probably hot glued in there. Now here's my little charge doctor. If I put this on here and just align everything, and this is probably what I'll do is have something plugged in just to hold it in spot, and then I'll obviously glue it. But you could see it covers over where I have the holes here for the LEDs and the switch. So of course now I can't really use this unless I flip it, and then I already have a hole for the LED that's kind of ugly. It's really not too bad. I can actually probably just build another one of these circuits, or just get a USB plug, like I said, from the dollar store, something like that. I may go that route still. And the other thing, the switch, I have it so it sits right in here. Let me turn another light on my camera here, and it sits in between these two posts where the screws go in, and it sits in there perfectly. But where I have the wire coming through, you can see down by this terminal, hopefully, it is kind of dark in there, but there is a little hole in the wall, and yeah, there you go, you can see light coming through it. That's where the wire is going to come through, but the switch sits kind of close to that, so I'll have to see how I'm going to route that. It will be a little tight in there anyway. I do want to kind of make it where I can still separate the halves and still be able to work on it if I have to. Also, I drilled a hole here, and that'll allow me to actually pass a screwdriver, or better yet, a trim pot tool, which I don't have, but I will pick up one, and I can be able to set that. Now I have it oriented this way. I had it flipped the other way around, and that's why I desoldered the wires from it for now, because it'll be a little bit easier to redo. But that drops in, and you probably could barely make out the little copper screw on the other side there, but it works out perfectly. If I hold the screwdriver into that hole there, you can see I can reach it just right. So that's pretty good. And once I get the wire soldered back in, that'll hold that back in the spot, because that's basically what was going on. The little wires that were protruding were just acting as a slide and friction and holding it in. I'm also going to take this piece of cardboard like this, and I'm going to wedge that in place, and that'll also hold it. And then it'll get, like I said, a little dab of hot glue in each corner. So that part, I'll say, is pretty good. And then the top here, and I still have the switch one way, switch the other way, and then that USB output. And I started thinking, why don't I just put some white LEDs in here, hook them both up together, and that way I can switch between having either USB output or two lights, and just have it as a backup source of light. And unfortunately, I don't have any 5mm white LEDs here right now, but I do have the orange, I have blue, I have red, I have green, I have yellow, I have a variety of other colors. Even I have UV, so I might even go that route, maybe UV, because that'd be kind of neat. I don't have any other UV equipment right now, but orange was pretty bright, so I was thinking, instead of a selector, you know, A and B, I could just use that, like I said, as a light output, because I already have an output LED for the USB output, so you know that that's on. So I have to still figure that out, but other than that, this is going pretty well. There really isn't anything else that I did other than just mess with these couple little pieces here and just get some stuff cleaned up. Now the two halves, it doesn't matter which way they go back and forth because it's symmetrical. They'll do the same thing either way, it looks like. I can confirm that actually. The back half for sure seems like it's the same, because you could see, but the top isn't, obviously, but it doesn't matter which side the top is, because the bottom is what's going to make the difference. But you do see there is a notch here, and on the other side it looks like the notch, but it's not actually cut out. They really should be the way it lines up, so I'm going to go with that the whole way. It's actually kind of funny that the AA holder is almost as big as the inside of this complete unit. And I guess this is probably the most efficient way to organize the batteries and have some kind of a support piece in the middle. But being able to hide the electronics into the middle of this is actually going to make this a really cool project, so I'm actually excited. One thing before I get too far, you probably are thinking, what about the batteries? How are they going to stay in? Because it doesn't seem like there's any way of holding it, and you're right. I plan on using probably a big rubber band and just putting it around it just to hold them in. That's the only thing I could think of. Or maybe get some Velcro strap and just strap it around. Ideally, I guess it'd be nice to have some kind of a rubber sleeve, maybe even, that would cover this completely. And I may even cover these extra points here with liquid electrical tape just to keep them sealed up, like I did with this battery here. Now, I did have to uncover one because I used this the other day for another project, and I didn't need the full 12 volts, so I just tapped off there and I just used 4 batteries in it instead, and I got the 6 volts, whatever it was. Yeah, it must be 6 volts obviously, because that would be 12 volts if there was 8, so 4 would give you 6. Makes sense. Anyway, let me go ahead and figure out what I'm going to do with the LEDs and how I'm going to actually implement that. There is some space on this board back here where I could possibly put the resistors if I want, and just have them in one little area and not all over the place. And then the LEDs, I was thinking, just if I'm going to use them together as a source of point light, I guess you could say, I'm going to connect it with the 2 negatives, or the ground wire, in the middle, and then the 2 positives on the outer side. And that way I could just connect it easier that way. I could also do these in series with 2 of them together with 1 resistor, but from experience from doing things like that, when you dip below a certain voltage, they no longer work, and I want to make sure these things work as far down as possible. So hooking them up to individual resistors, I think is the better way to go for that particular system. So I'm going to go ahead and do a little more tinkering here. Oh, and I should show one more thing. When you're working with LEDs, it's always worthwhile to use a tester like this before you solder them in to make sure they work. So I did that with both of these, but you can see they do obviously work. All right, let me do some more tinkering and we're right with you. And here we reach another one of those little impasses. So I did manage to solder a wire onto the rivet. Unfortunately, the rivet kind of came undone. The actual hole just melted, and that was to be expected. I should have thought better. Now, what I thought to do was to use a ring terminal here, actually terminate this onto the end of the wire, and then just rivet that in place. I do have a riveter. I can do that. I don't know if I have a rivet that small. We'll find out. The other thing is too, I'm gonna have to put it in this location. I can't do it here because I'm afraid of not being able to get these back just right, and those are going to be more critical than these over here. So now routing the wire, how am I going to do that? Well, I can't get these on the flip side here, which is where I originally wanted to put the wire. So I'm going to have to do it on the front side. So I'll probably put them here and then have the wires come out in the front here. I mean, it'll be ugly in a way, but it might enhance the look in another, because you know, it's going to give it more of an industrial look, I guess you could say. But I did also make the LEDs. Now you can see the middle here, it's bridged, that's the negative, and then you have 2 positives over here with the resistor at each end. And then the idea is when this sits inside, and I can show you upside down here, because this is actually how I built it. I just sat them in here and then used this as a kind of rough template. But if you put the switch next to it, you can see where the terminals line up. So all you need to do is actually just run these over to these 2 terminals like that, and then when you run the wires over to here for whatever device you want to power, they'll work that way. But it should be noted, this is a flip switch, so when the switch is in this position, it lights the LED on the opposite side. So realistically, these would be switched around, and that's important to note. But anyway, now I'm going to just do a little bit more tinkering around with this just to figure out a little bit more what I want to do here. And possibly go out and get my riveter and try to rivet these in. Instead of rivets, I decided to use these standoffs. What you normally do is you would screw in a screw or drill a hole and then mount this screw, and then you get the standoff, and then if you're putting a circuit board or something, you would put it on top of the standoff, and then you could put another screw in from the other side. So what I'm going to do is, after I drill these out, obviously, I'll put a screw in here which will pop out, and then I'll put the standoff on top of it. Then the standoff will give me a spot to clip, like an alligator clip to, and then I'll have threads if I want to put another screw in the other end of it to be able to connect more wires to. And what I actually end up doing is taking the blue little crimp protector or insulator, and I end up sliding that off because I'm going to slip heat shrink onto here anyway. And you can see I crimped it on, and I'm going to end up soldering it so it's double connected. And then this will allow me to have a nice flat surface so I can actually set that on here nicer. And I'll figure out where this is actually going to run. Now the white one is the positive input, and then there's going to be a blue one for the negative input. But I got to make sure this is out of the way enough where I can, still get to the screw, still get to the switch. So I'll probably end up having it go this way, and then I'll route it directly in. And it's going to go to the other side and connect right to the switch. So that's going to make that pretty easy. Well, I got the electric all taken care of now. You see how I actually went back to using white and black as the input and red and black as the output, using blue for the negative on the input, and making it white and blue was just a little confusing. But anyway, you can see everything's put together. We have just the two loose wires on the other side here. These are going to go to the posts as mentioned, and right away the black goes to like a little mini, what I'll call a little mini bus right here, and this is just the where I have a couple different connections at once, and that's where the LEDs also connect to. The other side of that, there's the two positives, and there's a resistor on each. They go right to one of the legs of the switch, so when you turn the switch in a certain direction, both LEDs will light. When you turn in the other direction, it'll power this, and you can see the white wire coming down to it, as well as the negative. So that's your positive and negative, obviously, and then it'll get converted and then go out to the board, and then this green LED will light. And we can actually do a little test run. I have two alligator clips here, and this is coming from my bench power supply. I have 11 volts coming in, and if I connect black to black and red to white, and we can flip this over, you can see the two LEDs are glowing right now. If I put the switch in the middle, they shut off, and we can see the other unit's not lit. And then when I turn that on, now we can see the green light's lit. If I want, I could take my charge doctor and plug that in, and you can see we're getting 5.07 volts. And I have a little Arduino over here with a LED cube in it, and we can plug that in. We can see the amps goes up to 0.5 milliamps. And this thing's of course working. And if I need to, I can still adjust this, because once this is put into the case, I still have that adjustment screw area. So now what's left to do is mount the switch and the LEDs in the holes, put a dab of hot glue behind the LEDs to hold them in place, and put the retaining nut on the switch to hold that in place. Slide the control circuit here, the actual converter, into the back of the shell here. Again, a dab or two of hot glue just to hold that in spot. And then the last thing to do will be to actually mount the USB into the front. And again, that's the same thing, just a little glue. And then I'll put the two cases together. I'll put the wires in the front on the posts, and I'll have to get batteries, so I have to stop filming for tonight so I can get batteries tomorrow. but we'll come back once I have everything actually assembled. Well, here's what it looks like all together. It went smoothly. Everything just kind of fit together, and the wires kind of found their own way, and just screwed it together, and it's nice and solid. And it's nice, you know. I like the way the wires look in a way. I mean, it gives it kind of like a battery effect, I guess you could say. And we can actually test this thing out. I made up a little wiring harness here, and this has just got 2 eyelets on one end and 2 banana plugs on the other that I could plug right into my power supply. So we can use that to test it out and calibrate it. I have a really thin screwdriver to get in there. And we'll also use the multimeter. Now you can see I have it right off here in the corner. And what I did was I took, and this is a while ago, I took a lead for the charger for my cell phone, and I actually cut the end off of it and resoldered it to one of these little boards that I make a lot of projects on. And there's just 2 little leads coming off of here now. I added these pretty recently, but I'll be able to take the output from that here and take alligator clips, connect them like so, and then we'll be able to see what the output is. And that way it's just easier just to plug this straight in than the charge doctor. I do plan on getting another one of those charge doctors that actually fits in long ways instead of sideways like the current one I have does. And hopefully I'll be able to get one of those pretty soon, because they are a little nicer. But you can see here's the little adjustment hole right here, and the only thing I really have to do is pick up batteries to really give this a good test, but we can pretty much do without it for now, just hooking it to the power supply and calibrating it. Now you can still use this afterwards in kind of the opposite effect, connect it to here, and then you'll get 12 volts out here, and you can use this to connect to a breadboard. I happen to have one that has 2 banana jacks on it that you can plug these right into. Or you can just undo these little screws, they'll come off, and you can put maybe alligator clips on the end of it and use it like that, and then that turns that into a good battery pack. So there's definitely different things you can do, and it's nice gauge wire, and pretty much with the posts and the eyelets and the wire going in and everything, it pretty much all matches, which is nice. So let's give this a little test and see what happens. So I'm going to go ahead and just attach this and get it hooked to the power supply. Okay, so this is the power coming in from the power supply, and we can see we have the meter in the corner here. So if I go ahead and hook up the clips to what's coming in here, and we'll actually flip around, get the polarity right here. We see we have 11.82 volts. And of course, if I turn this on in the down direction, we get those little orange LEDs lighting up. If I flip it in the middle, it's off, and if I flip it up, it'll light up the green LED indicating that the USB port is active. I should be able to now take this and plug it in, and we can move the alligator clips over to these bare wires here, and we'll see we're getting 5.08 volts. So that's pretty much spot on. I could take the other end of this here and take my cell phone, which is off camera here, and just plug it in and put some kind of a load on this and see if it jumps down. Now the phone is indeed charging, and I can tell you the phone's charger is nowhere near what my tablet can draw. So if I go over and take my tablet, which I also have right here, now this time I'll have to disconnect this whole assembly here, which of course is going to kill our multimeter, but I can plug in the tablet and connect that, and it did light up and it is charging. So that's great. It is putting out the proper current to charge my tablet. Now the question is it regular charge or is it a trickle charge like you would if you were using a lower amperage charger? So anyway, with that, I'm going to cut the video for now. I'm going to go to probably bed soon and go to work in the morning and grab some batteries on the way home. And when we get the batteries in this thing, then we can really test it a little further. Now, if I wanted to adjust this before I do anything any further, I can just flip it up like this, stick the screwdriver here, and tweak that voltage, but that's pretty much spot on, right where it should be. Pretty much going to leave it just as it is. Well, it's been a couple days since I last touched this project, because I got involved with the weekend. But anyway, I called my wife the other day on the way home from work and said, I got to stop and pick up some batteries. She says, I'm already in the store. What do you need? I said, pick up 8 D cells. Please make sure they're alkaline. I didn't specify a brand. She picked up these Everready Gold batteries. I've used these before. They actually are pretty good. Everready is a really old brand. They've been around for quite a while. As a matter of fact, I'll show you. I have one of these 45 volt batteries from Everready. It's quite old. That's why I have it in the bag here, just to keep from leaking all over the place. But anyway, you can see this thing works pretty good. I can flip the switch on. We get the LEDs or the little, charge circuit. And I already tested this out. I had to charge my tablet. No problems at all. It's got some good heft to it. You can see I just put a couple rubber bands around to hold it on. I might put some rubber feet in the bottom just to make it more stable. But it does sit actually any way you really want it to, which is nice. I saved the packaging for these batteries just to show you. It's one of these little, 4 packs, whatever. I got 2 of them, obviously. But they have this little bit of marketing wank, we'll call it. It says it lasts up to 3 times more, but in the little fine print it says versus Everready carbon zinc batteries. Well, of course it lasts longer than carbon zinc. They're low drain batteries. They're not meant for high drain, devices. So of course you want to go with an alkaline in this situation. Anyway, guys, I don't really have much more to say about this particular thing. I thought it was pretty cool myself. Hope you guys thought the same thing. Oh, I will show, I went ahead and made up a small harness. I still have to put the little eyelets on here so you can have these the alligator clips if you wanted to use this as a 12 volt battery. And I also took the little USB 2.0 amp little charger circuit here with eyelets, so I can connect those on here. So if I wanted to charge actually 2 devices, I could do that. This is obviously going to be the higher current output, up to 3 amps. This one's going to do 2. So this one's good for your cell phone or your my camera maybe. This one's going to be better for those high drain devices like I said, the tablet and whatnot. And this is going to be it for this. Unfortunately, my computer died, which is not a good thing. And it's not one of those things that seems like it's going to be an easy fix. And given the age of it, I think I might have to break down and buy a new one, or at the very least try to reinstall Windows. It's one of those things that you don't ever want to see. The computer worked fine yesterday. I put it to sleep usually, but this time I shut it down, and I came home and turned it on, and it wouldn't come back up. And tried all night, wouldn't come back up. Tried everything, wouldn't come back up. It's a Windows 10 machine. It won't let me restore to a system restore point because there isn't any. I don't have a system image saved up. I don't have any of that stuff. I do have a backup on my server, but that's a backup within the Windows Home Server thing. It's not the actual Windows 10 backup image that I need. So I can get the computer up and running, get it back in the Windows 10 environment, and then back up all my stuff. But it's kind of a silly way to do it, because honestly, I have all my files stored on the server. I mean, even the stuff I do with my camera, when I'm done with it, it goes onto a separate hard drive. And the hard drives are fine, I can read them. I just can't get into the Windows environment. So it's going to be definitely something I'm going to have to fix. I think for now, I'm just going to have to try to edit this video on my wife's computer. Luckily, I have that in this room, and it's still a pretty good machine, so it's comparable to what I was using, just maybe half the RAM. But anyway, let me go take care of that, and we'll see you guys next video. Thanks for watching.